Let's take a look at number 23 in section 5.4. We're going to write the given integral as a sum of integrals without absolute value, right? Real important, without absolute value, and then we're going to evaluate them. Here they want us to use decimal notation and give your answer to 3 decimal places. Again, some of you know how to use your calculator to evaluate this, and you can round your answer to 3 decimal places, and you can get this one correct. But on a test, that's going to give you 0 points. Okay, you have to write it without absolute value, and then evaluate. We're going to evaluate that using the fundamental theorem of calculus, part 1. So all you need to do to evaluate this is, think about the graph of the cosine function. I've graphed it here for you. Right at 0, it's 1. Pi over 2, it's 0. Pi, it's -1. 3 pi over 2, it's back to 0. And then 2 pi, it's back to 1. And we continue on, right? In fact, we're looking at pi over 8. Here's pi over 2. Halfway to 0 would be pi over 4, and halfway again would be pi over 8, right? So there's pi over 8, and then we're going all the way up to pi. And you can see we're integrating the absolute value of cosine of x. So from pi over 8 to pi over 2, that's fine because the absolute value of cosine x is just equal to cosine of x. But from pi over 2 to pi, this area would accumulate as negative area. We want to multiply it by -1 and essentially pop it up here, right? So that we're really, that would be the graph of the absolute value of cosine of x would come up here, right? Up to +1. Basically, the absolute value of cosine of x is going to be equal to cosine of x, for instance, for all values of x between -pi over 2 and pi over 2, because the graph of cosine of x is above the x-axis, or non-negative, right, on that interval. And then from pi over 2 to 3 pi over 2, since it's below the x-axis, the absolute value of x would be -1 times cosine of x. So this shows us how to write this integral as a sum, in this case, of 2 integrals without absolute value. So the first integral will go from pi over 8 to pi over 2, and we'll simply integrate the cosine function because, again, for values on that interval, the absolute value of cosine of x is just cosine of x. And then we'll add from pi over 2 to pi. Of course, we'll integrate negative cosine of x because on that interval, the absolute value of cosine of x is indeed negative cosine of x. So this is the first part. You have to have this down. This is the first part of the answer, right? Rewrite the integral as a sum of integrals without the absolute value. And there they are. Now we can evaluate each one using the fundamental theorem of calculus. Recall the antiderivative of cosine of x is sine of x, right? And then plus negative cosine of x or minus cosine of x, the antiderivative is negative sine of x. This first one we're evaluating at pi over 2, and then at pi over 8 and subtracting. And the second one we're going to evaluate at pi and at pi over 2 and subtract. Okay, well, sine of pi over 2 is 1, so both of these are 1. Excuse me, sine of pi is 0. And so simplifying, I got 1 minus what? 0 minus 1 is -1. 1 minus a -1 is 2. And then we still have this minus sine of pi over 8. Now, I don't know what sine of pi over 8 is off the top of my head or with the unit circle. And so I will just use technology, making sure, of course, that I am in radian mode when I evaluate this. Hit the mode button, make sure you're in radian mode, and then I can evaluate that expression. And they wanted it to 3 decimal places. And so, of course, it's going to be 1.617. Be real careful. If this 3 were a 5 or more, we would round it off to 1.618. Okay, hope this is helpful on this one.